Alright, this video here is going to walk you through the solutions to the warm-up review. The first thing you need to do is remember when solving inequalities is to solve them just like equations. However, the one point in time when you find yourself dividing or multiplying by a negative number, you need to remember to switch this inequality around. The first thing when you solve this, to get x by itself, you're going to first subtract 5 to both sides. Then when you subtract 5, you'll get 15. When you subtract 20 minus 5, you get 15. Then, to get this negative 3 out of here, you're going to divide by a negative number and get x is greater than negative 5. Now notice what happened here. It was staying the same direction the whole way through, but then when we divided by the negative number, hopefully you also remembered to change it around and say x is greater than negative 5. Now we have to also be able to express this answer on a number line. When you're making a number line, you're going to put negative 5 at the bottom, and then you're going to also decide if you're going to include it. When there's no equal to symbol in this statement right here, then you're going to leave it as an open circle, okay, like you see right here. Then decide what x values that are greater than negative 5, they're off to the right. Okay? Hopefully in this question you were successful getting both parts to the answer. We want you to be able to express it as an inequality and as a number line solution. Number 2, what we have here is a quadratic that involves an inequality as well. This kind of problem you want to solve just like an equation. So let's change it over to an equation like this and get 2x squared plus 14x equals negative 20. Now there's ways to solve this. When we solve quadratics, you also want to get the terms all to the same side of the equal sign, like you see here. Then that helps you decide if you're going to use a, b, and c in the quadratic formula. Or you might try to factor it. This thing will factor nicely as well to 2 on the outside, and then x plus 2, x plus 5. And then using the zero product property, you realize that x equals negative 2 and x equals negative 5. So our goal in this whole process is when we solve this inequality, if we solve it like an equation, we're trying to find the boundary points. So had I used the quadratic formula also, I would have got x equals negative 2 and negative 5. Now, since I have that much so far, I need to put these numbers on the number line. When you put these on the number line, you want to remember, should I be including them or not including them? Since this question had an equal to symbol in it on the number line, I want to have solid dots. So as you can see here, I have my numbers at negative 2 and negative 5. I have solid dots. The next thing you need to do is test out a point. The number 0 is very easy to test. So if I go up here and test out the number 0, I'll have 0 plus 0 is greater than or equal to negative 20. Is 0 greater than negative 20? And the answer is yes. So where 0 was, it worked. So therefore I have an arrow going out to the left. You could have also tested the number in the middle here and notice it did not work, or test out the number negative 6 up here. You'll also notice that it does work when you put negative 6 in this equation up here as well, or this inequality up here as well. So since your boundary points and the numbers tested out the way they did, the arrows go outward. Now the way you say this statement as an inequality is it's two parts. There's a part going left and a part going right. There are two different parts to this solution. So the way we say that is an OR statement. We say all the x values that are less than negative 5 or all the x values that are greater than negative 2. That's how you solve this one. Next, number 3. We have an absolute value inequality. The first thing you want to do on these kind of problems is get the bars alone. So just use your normal algebra skills. You're going to first of all subtract 3 to both sides, getting the 3 over here, and get x, or 4 times the absolute value of x minus 6 is less than 20. Then I want to get that 4 out of there. I'll divide the 4 to both sides and hopefully get x minus 6 is less than 5. Now once you got this far here, let's try to think of it now as an equation because you can get the boundary points. When you solved these in the past, you had two answers, one where x minus 6 equals positive 5 and one where x minus 6 equals negative 5. When you solve those equations separately, then you found the boundary points and got x equals 11 and x equals 1. Again, when I put these numbers on the number line, I have to decide, are these numbers going to be included or not included with my answer? Since I have a less than symbol, there's no equal to there, then it's not going to be included. So I want to make sure I have open circles on my answer. So what you'll see is my numbers 1 and 11. It's kind of hard to see there. And then my solution, then I have to decide where it's going to be. So if I test out a number between these values, like the number 2, going back to this statement right here, if I put 2 in for x, I'll have 2 minus 6 equals negative 4. However, the absolute value of negative 4 is positive 4. 4 is less than 5. So the number 2 does work. If I tested out 0, 0 minus 6 is negative 6. The absolute value that is positive 6. 6 is not less than 5. So 0 did not work. Outside did not work. And when you see these problems that you solve that have two solutions to them, typically in this chapter you're going to find if they don't work on one side, they won't work on the other side. This one it did work in the middle, so we have our answer in between. The way you say your answer is in between algebraically is to say 1 is less than x, which is less than 11. That doesn't really make sense because I said less than twice. But if you read the answer from the middle, it makes more sense. We're saying all the x values that are greater than 1 and also less than 11 are part of the solution. Okay? That's called an AND statement when we have a statement where it's read as like you did with domain and range. Next, we had to graph a sketch of this equation, or this inequality right here. When I have y is greater than, there's some things you need to consider. If it says y greater than, we're going to not include the graph. If there was an equal to symbol in our equation, then you want to include it. So then I'll have a solid graph. Okay, so since we don't have this graph being included, the way we express that is with a dotted line. So I have the graph moved over 3 to the left, and then, 2 to the left and up 3 for my vertex. The graph's opening upward because I have a positive stretch factor, and then I'm shading on the inside because it says y greater than. All the y values that are greater than something are above the graph. If it says y less than, then the expression over here, it'll be all the things that are below the graph. So this one here, your graph hopefully looks like this, and hopefully you were successful getting your solutions. Good luck, and hopefully you'll have more success.